Hello everyone, I'm Xinbin Hou from China Academy of Space Technology. Today I want to introduce the activities in China and talk about several considerations. First, thank you very much for your invitation. Today I want to introduce three parts. The first one is recent activities in China. And in this slide, you can see some important activities in China. And on the top, you can see some important research activities and some important conference in China. And on the bottom, you can see some important international communications, include some important international conference. And the Committee of Space Solar Power, Chinese Society of Astronautics, was established in 2021, and Professor Ming Li is the chairman. And we held the first conference in 2022, and last year in Yangzhou, we held the second conference, and this year we'll hold the third conference in Qian. And last year we held the first Chinese SSP competition for youngs, and over 40 teams registered for a competition, and 10 teams stepped to the final. And the final top three teams are from Xuesen University, Sichuan University, and Yangzhou University. And the second SPS competition for youngs will be launched next week. And there are some publications related to space solar power. Introduction on space solar power. And space solar power, that's translated book, and the original also is Professor Shinohara. And space solar power in illustrated introduction. And this book will be published in English by Springer Publisher this year. Another one is the Principle and Technology of MPT, and Dynamics and Control of Space Solar Power. And the last one is a science fiction. It's Zhu Record of Space Solar Power. We also have a journal in English, Space Solar Power and Wireless Transmission, and it's an international journal jointly sponsored by Chongqing University and the Committee of Space Solar Power. And you're welcome to publish your papers in the journal, and you're welcome to join to be an international editor. And we also hold and attend some activities of popular science and outreach. And last year we hold a series of 4 lectures online for public. Over 15,000 audience listened the lectures, and I also attend several important energy summits to introduce SSP, and we also participated in several activities of popular science organized by in Beijing Association for Science and Technology. And now I want to introduce researchers on SPS in China. And first is about system research. Maybe as you know, China proposed the two type solar power satellite concepts. The first one is MRSPS proposed by CAST in 2014, and in 2021 we proposed another update concept, MMRSPS. And in 2040, Xidian University proposed another SSPS Omega concept. And for solar power satellite, it includes several characters, heavy mass, large area, high power, high efficiency, and long life, and low cost. That means we must conquer some key technologies, including wireless power transmission, high power electric power generation, transmission and management, and space super large structure assembly and construction. And in technology research, first we mainly focus on the MPT-LPT. That's been studied and demonstrated by many organizations in China. And some good news in last year is the best rectifying efficiency is over 19%, and the laser to DC efficiency is over 70% for 808 nanometer laser. And we also do some research about the advanced solar cells, high power electric equipment, and large scale structures. And now the thin film PV efficiency is over 30%, and the demonstrated voltage is over 400 volts on ground simulation facilities. We also have two experiment bases. The first one is B3 Space Solar Power Experiment Base, has been set up in Chongqing. And the research field include MPT, LPT, high voltage electric technology, and the environment effect of high power wireless power transmission. Another one is Zhuri project. It's a full system ground experimental demonstration system based on SSPS Omega concept, and a whole system demonstration was carried out in 2022. And the output RF is the power is about 2 kilowatts, and the total efficiency from DC to DC is about 50%. And this is the proposal roadmap by Chinese expert in 2050. It includes two milestone stage. The first one is the megawatt system demonstration, and the second is a gigawatt commercial system. And in 2022, CAST proposed another roadmap that's mainly based on MRSPS concept. As you can see, it includes 4 steps. And the first one is to demonstrate some key technology in LEO. And the second stage is to demonstrate the key technologies in GEO. And in 2035, we want to construct the first megawatt payload system. And in 2050, we'll construct the gigawatt solar power satellite. And for the first mission, it includes 2 spacecraft in LEO and a receiving system on ground to evaluate the validity of some key technologies of SPS in space. And on the right, you can see the configuration about the satellite. The emphasis of the mission is to validate the theoretical energy chain and long-distance beam control precision. And the solar array and the antenna emitter are similar as the design of megawatt SPS. And this is some specifications about the mission. And the orbit is SSO, and the the transmitted RF power is about 4 kilowatt, and the laser power is 1 kilowatt. And the output power for the thin film solar array is about 10 kilowatt, and the watt is about 500 watts. And here so the experiment mode of the mission. It includes 5 modes. And in this figure, in this table, show some experiment time for the MPT-LPT. And here shows the MPT demonstrate system. And on the left is the configuration about the MPT system. And it includes 4 antenna sub-areas, and each sub-area is about 1 meter size, and it's multi-layer structures. And here shows the specifications about the MPT demonstrator system. And here shows the LPT demonstrator system, and on the left shows the system and subsystem of the LPT system, and also shows the LPT efficiency chain is transmitted to the ground. And on the right, you can see the parameter about the LPT system. And for the second mission is a GEO high power WPT demonstrated mission. And it includes 1 spacecraft in GEO and the receiving system on ground to evaluate high power electric system and very long distance WPT and assemble technologies in space. And we propose the module are launched to LEO and assembled here. And the WPT experiment will be conducted in LEO firstly. Then the spacecraft will transfer to GEO and demonstrate WPT in GEO. Of course, the system for some important module and some sub-area are also similar, similar as MIG-world SPS. And this is a specification for this mission. And we proposed the RF power is over 100 kilowatts, and the laser power transmission may be about over 10 kilowatts. And for the thin film solar array, the output power for one module is about 50 kilowatts, and the total power is over 400 kilowatts. And for the receiving system on ground, because it's a very long distance, so the density is very low, so the efficiency is low. Finally, I want to talk about 2 considerations on space solar power development. The first one is about the roadmap. I think it's difficult to define the logical development phases before the commercial SPS stage. And I think the first step is a small mission, and in fact that has been or will be carried out by different countries to demonstrate several key technologies in principle. But the difficulty is the second step. I think it should be big and complex enough to demonstrate meaningful key technologies. That means lots of budget. And of course, the most important milestone mission is the full system payload SPS. But how about the time, the orbit, the key specifications, the cost, and the necessary supporting infrastructures? That's difficult to decide. And the second consideration is about international collaboration. For SPS, such a prospective mega program, the closely international cooperation is necessary. And how to promote quick purpose of SPS by efficiency international cooperation is very important. I think maybe the first step should be to establish the formal international organizations to set necessary international regulations, policies, and standards on SPS. But the baseline roadmap, technology parameter, and evaluation standards are also very urgent for the researchers all over the world. Okay, that's all. Thank you very much. Will contact me by my email. Thank you very much. Bye bye.